Permutations. Hi, my name is Arul, and I'm going to teach you about permutations. Well, what is a permutation? A permutation is a number of ways a certain set of things can be arranged, where the order matters. Permutations can also be known as arrangements. So, an example of this is how with the letters A, B, C, we can make many different arrangements. Now let's see how many we can make. So, we know that if we wanted there to be a combination that started with A, one possible one could be ABC, but another one could be ACB, where we just switch the orders between these two. Now, if we were to make a three-letter combination that started with B, we could do BCA, or we could also do BAC and switch around the letters like we did for the other one. And if we wanted a three-letter arrangement that started with C, then we could do CAB, or switch these around and also write CBA. So this results in 6 different arrangements. And as we said, arrangements can also be known as permutations. So there are 6 different permutations. Now, even though all of these letters here, they're all the same letters, but they're arranged in a different order, which differentiates all of the permutations. So permutations aren't only applied towards finding the total number of possibilities by arranging a set, and can also be used in many different ways, from finding how many different 2-lettered words there are to how 4 letters can be put in 4 envelopes. Just like how finding how many different 2-lettered words there are, we can also try to find how many 2-digit numbers there are, where all the digits are distinct. Distinct means different. So how many 2-digit numbers are there where both of the digits are different? Now let's see. So I'm going to write, this is going to be the tens place, and this is going to be the ones place. So I'm just going to do this with right here. So if we wanted to see how many different numbers that could be that are possible choices for the tens place here, let's see how many we could put. So we could do 1 or 2 or 3 or 4, 5, 6, 7, 8, 9. This shows 9 different options for the tens place. But you might be thinking, why can't we put 0 here? Well, we can't put 0 there because then the 2-digit number itself would become a 1-digit number. And we can't put 10 there because then it would become a 3-digit number. So the only possible choices for the tens digit would be one of these 9. So we know that there are 9 choices. Now, if we were to find possible choices for the ones place, let's see. We could again do are 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we were to add a 10, it would again make it a 3-digit number. So a 10 would not be possible, but we could do a 0 because we're in the ones place. So 0 isn't the starting, so it doesn't make the whole, like the 2-digit number into a 1-digit number. So a 0 is now an option. But if you remember, the problem is asking distinct digits. So all of the digits have to be different. So for example, if in the 9 options I have here, if I chose one of them, if I chose, for example, I chose for my tens digit right here, I chose 2. So if I chose 2, then for the ones place, I can't choose 2 again because all of the digits have to be different. So if they're supposed to be different, then I can't repeat it, can I? So what you would have to do is in the 10 possible choices that you have here, you would have to cross out the 2 because it's already been used in the tens place. So that leaves you with another 9 choices. So here is what we're going to be solving the total number of possible arrangements here. So we know that there are 9 possible choices for the tens place because 0 cannot be a choice and 10 cannot be a choice. And for the ones place, 10 cannot be a choice, but 0 can. But that doesn't mean that the digit that you've already put for the tens place can repeat in the ones place. So you would have to subtract 1 from those 10 possible choices. So that would result in 9 possible choices for both each of the tens digits place and the ones digits place. So you would do 9 times 9, resulting in 81 possible 2-digit numbers where all the digits are distinct. So just like how we did that for 2-digit number, let's try that with a 4-digit number. So also, if you were to think, why are we multiplying here? That's because you could try this by using a table. And if you were to use a table, you would see that there would actually be 81 possible arrangements. So you would have to multiply. Now, if we were to do this with a 4-digit number, just like how we did over here, we saw all of the possible values that could be there for every single digit's place. So we're going to do the exact same thing here. So starting off with the thousandth digits place, let's see what values we could have. So 1, 2, 3, 4. As we said before, we can't do 10 because then that would make it a 5-digit number. And we can't do 0 because that would make it a 3-digit number. So 0 and 10 are not allowed. So that would result in 9 possible choices. Now let's do the same thing for the hundredths digits place. So we can do 0. And we can do all of our normal digits. So I'm just going to go to 9. But we still cannot do 10. And this problem doesn't ask for all of the total number of all the possible 4-digit numbers there are. It's asking for the total number of different 4-digit numbers, like where all the digits are distinct. So again, if our 4-digit number started off with 1, then the other digits could not be 1. So then we would have to not be able to choose 1. That results in 9 choices. So just like how we can see that this is very similar to what we did for the 2-digit numbers. Now let's do the same thing for the 3-digit numbers. And we're going up to 9 again. 0 is allowed, but 10 is not. So now, let's say for the hundreds digits place, you chose the number it started off with a 9. It was 9, the hundreds digits place. That means that the other digits here, they both cannot be 9. So you would have to cross out 9 and 1, because 1 was already used for the thousands digits place. So that would result in 8 possible choices for the tens digits place. So then you would have to multiply by 8. So now let's say for the tens digits place, you chose, like the number was 3. So if the number was 3, that results in, for the ones digits place, the only possible values could be 1. It can't be 1 or 3, so it automatically goes to 2. And 4, 5, 6, 7, 8, and no 9, because 9 had been chosen for the hundreds digits place. So this results in there only being 7 options for the ones digits place. So that means from here you would have to multiply this to find the total number of possible 4-digit numbers where all of the digits are distinct. So, and from here, the ones digits place value could be any one of the values that we see here. So if you were to multiply this, you would result in 4,536 possible arrangements. So this is how you would use permutations when trying to find the number of possible digits for not a certain number. But notice how here this has conditions. So the condition that we saw here was that that all the digits were required to be distinct. So, but what if we had to do this where all the digits didn't have to be distinct? Then we see that just like how we did here, the first the thousands digit would be the same because it can't be 0 or 10. So there would be 9 options. But after that, 0, 1, 2, 3, all the way to 9, there's no requirement where a digit can't repeat. So that means this has 10 possible choices for this. And for the next one, the digit can also repeat again. So, and 0 is allowed. So there can be 10 possible choices for the tens digits place. And same thing for the ones digits place. So there are 10 possible choices for the ones digits place. This results in 9 times 1,000. So there are 9,000 possible arrangements for where the all the for 4-digit numbers. So this shows that there are 9,000 4-digit numbers. Now that we've learned how to do this, let's try to find the total number of ways, but with conditions. So if we were to do that, let's see this question right here. In how many ways can 2 prizes be given to a class of 10 boys without giving both to the same boy? So the first thing that we're going to do when we see this problem is we know that there are 10 boys in the class. Sorry. Question 5. So there are 10 boys, and there are 2 prizes. So let's just list the information that we have. So in the 10 boys, each one has a possible chance of getting the first prize. Like, all 10 boys could get the first prize. So for the first prize, there are 10 boys who could get it, right? But for the second prize, there are only going to be 9 boys who could get it. You might wonder, why 9? Well, this is because the question says without giving both to the same boy. That means, just like how we did here with all the possible numbers, if in the 10 boys, let's list it again. So if we went to 10, in the first 10 boys, let's say the last boy, the 10th boy, got the prize. That leaves only the other 9 boys who have a chance of getting the second prize. So that results in 90 different ways, and 90 ways, not different, 90 ways of 2 prizes be given to a class of 10 boys without giving both to the same boy. So 90 ways. But now, let's see this. For question 6, it states, in how many ways can 2 prizes be given to a class of 10 boys, it being permitted to give both to the same boy? So it's the same number of boys and the same number of prizes. But the only thing that they said differently is that both prizes can be given to the same boy. So that means all the 10 boys can get the first prize. So there are 10 boys who could get the first prize, and there are also 10 boys who can get the second prize. So this results in there being 100 ways for the boys to get both the prizes. So let's recap this. It is shown that in question 5, there is a condition where both gifts are not allowed to be given to the same boy. So this causes there to be a lower amount of ways to solve this. Then we're in question 6. There are no conditions. The emphasis of when the questions has a condition or like a restriction, that like deeply affects the answer. So make sure to check your answer by seeing if it were to have a restriction. Then you could see that there would be most likely a lower number of choices. So lastly, let's see a problem where just like this, there have to be a different number of ways. So let's say 4 competitors, they run a race for 3 prizes. In how many different ways is it possible that the prizes may be given? So let's list this. This is the first prize. This is the second prize. And this is the third prize. Now, the question really emphasizes how many different ways is it possible that the prizes may be given. So we realized that the 4 competitors they all have a chance of getting the first prize. But once in the 4 competitors, once one of the 4 get the first prize, that leads there to only be 3 people to get the second prize. And if there are only 3 people who could get the third prize and one of them wins if there are only 3 people who can get the second prize and one of them wins the second prize, that leads there to be only 2 people who can get the third prize. So you would have to multiply these values, and that would result in 12 times 2. So there are 24 possible ways for the prizes to be given. So this is how permutations work.